Okay, when I walk up to this integral, I'm asking myself, is it algebra, trig, or a mixture of stuff? Well, this is a mixture, so my first instinct is to kind of check for a u substitution. Well, the derivative of x squared is 2x, and I have a bunch of x's over there. It's not entirely going to get rid of my problem, but it is probably a good start. If I do a u substitution on this, and I let u equal x squared, that will make du 2x dx, which means over here, I want to borrow one of the x's from that x to the 7th. And think about that x to the 7th as x to the 6th times x, e to the x squared dx. Now, if this is my vocabulary list, then x dx would be 1/2 of du, and that piece I can take care of. So the x dx becomes 1/2 du, and I know that e to the x squared becomes e to the u, but that x to the 6th out in front, I still have to translate that into something in terms of u's. If u is x squared, then x to the 6th means that I've cubed both sides here. So u cubed would be x squared cubed, or x to the 6th, which means that x to the 6th gets replaced with u cubed. This question, it looks better, but I'm still going to walk up to it and say, is it algebra, trig, or a mixture of stuff? It's a mixture problem. There isn't really another u substitution to do, so we would be thinking about integration by parts. This happens to work out really well for that tabular method, because I know that with that u cubed, we're going to have to integrate by parts 3 times. So if I needed to finish this problem off, I would probably switch into the tabular method for integration by parts. So I'll kind of just hold on to that 1/2 for a second and come off to the side to think about our tabular form. This is a mixture of algebra and exponentials. Since a comes first in the word late, I know that u cubed is the piece I would be taking derivatives of. So I'm going to start off with my u's and my dv's. So I'd have u cubed, take the derivative, I'll get 3u squared. Another derivative, I'll have 6u. Another derivative, I'll be at 6. And I need to take these derivatives until I get down to 0. Now I need the corresponding integrals. So we started off with e to the u. And the good news is that when I integrate e to the u, I get e to the u, and then e to the u, and then e to the u, and then e to the u. And then we come in here and we take our diagonals. That'll be a plus and a minus and a plus and a minus. So stacking that all together, I'd end up with u cubed e to the u minus 3u squared e to the u plus 6u e to the u and minus 6 e to the u plus a constant. And then don't forget, don't do all of this work and then forget to plug in what u was at the very end. If this had been a definite integral, then I would have changed my bounds and I wouldn't have to plug those x's in. However, because it is an indefinite integral and I don't have bounds, we've got to plug this back in at the end. So I'm looking at 1/2 x squared cubed would actually give me x to the 6th e to the x squared minus 3. If I square x squared, I'll have x to the 4th. So 3x to the 4th e to the x squared plus 6x squared e to the x squared minus 6 e to the x squared plus a constant.